Okay, I've got 10 o'clock, so we'll go ahead and get started with the presentation. I'm sure some other folks will jump on here, but we'll go ahead and get started. And this presentation will be recorded for those that can't make it, so we'll make sure to also make the slides available and ship those out for everybody. And for information that's shared on the slides, there'll be a lot of links and stuff, so I'll make sure those are available for you that have attended, that you can click on those and further investigate when you have the time. So just a real quick introduction to those that I have not met before. See a lot of familiar names on the list of attendees here, but some I'm sure I haven't met. My name is Tony Edwards. I'm the Warning Coordination Meteorologist with the National Weather Service here in Charleston. And I'm pretty much the liaison with those folks that use our products and services. So I make it out to a lot of meetings, do a lot of outreach like this presentation. And so if I haven't met you yet, hopefully one of these days in the near future I will, and we can chat. But anytime you have any questions, concerns, issues with our products and services, just want to know more about them, don't hesitate to reach out to myself or really any of our staff here at the Charleston National Weather Service office. We'll be happy to help you, but I'm the principal interface, the liaison with the emergency management community and the others that use our products and services. Just a little housekeeping with the GoToWebinar if you're not familiar with this. The easiest thing to do as far as questions is if a question pops up in your mind while we're going through the presentation, is just type it in the questions box on your screen there. And then once we get done with the slides, I'll go through those questions and we'll check those out and answer those as we see fit. If something happens and I was to drop out or you can't hear me, just also type that question in there. I'm monitoring the questions out of my right eye and looking at the slides out of my left. So if anything pops up like that, you can communicate with me by that questions box. I'll see those. And but then at the end, I'll go through and we'll answer any questions and go that direction. I'm doing this by myself, so it's typically the easiest way to handle questions. And if you don't see the little dialog box, it's probably minimized, so you just want to click on the orange arrow that's on your screen. Okay, so here's the agenda, things I want to cover in this presentation. I want to talk about forecasting winter weather and why it's so hard to forecast winter storms, and particularly in our region. We have some special challenges that we face here in our region. Every meteorologist thinks that it's, their area is the hardest to forecast for, but I'll show you why that is especially true here, why we need your ground truth reports and how to get those reports to us, and why they're so important. And then we'll talk about some forecast resources and products and any changes in those products that you may be already familiar with. I want to take a look at a few case studies of some problematic winter weather scenarios, not the normal, well, it's going to snow 4 inches, it's going to snow 8 inches, a couple of kind of odd cases that we have to deal with, usually once or twice a winter here in our region. I want to go through those. And then we'll talk about the winter outlook and what it means for our region specifically. So let's talk about forecasting winter weather and specifically when it comes to forecasting winter weather, we need 3 key ingredients. And you can see an idealized winter storm here on the map in the Central Plains where you have snow on the west side of the low pressure system, a mix to the north of the warm front, and then even some thunderstorms east of the cold front. But to get the winter storm, you need cold air for sure, and moisture. And that typically comes from our region, from the Atlantic Ocean or Gulf of Mexico, but we can also get moisture from the Great Lakes and get snow that avenue as well, which we'll probably get some of that this coming into this week. But you also need lift, and typically that's in the form of low pressure, a frontal system like you see on the map. For our region and for anywhere, really surface low track is extremely important for who gets what. And we did some research here locally, looking at our climate sites and looking at the top 10 winter storms in the history of those locations. And I'll show you, you can see the track of the low pressure systems. I'm starting with Huntington here on the map on your left. And notice the track typically comes up from the Gulf of Mexico or Alabama, Mississippi region, and then tracks northeast up through the Piedmont of South Carolina, North Carolina, into Eastern Virginia. And as I step through locations, here's Charleston. You can see very similar low pressure track. Here's Parkersburg, very similar. Elkins, again, very similar track. And then you get to Beckley, similar track, a little bit shade further to the east. And there's a few anomalies, some different tracks in here. You can see Beckley, October 2012, that's Superstorm Sandy, the snow that was produced there. You can see how odd of a track that system was. But typically that track is really consistent, and really Norfolk, Virginia, that southeast corner of Virginia, if the low pressure track's within 100 miles, 50 miles either side of Norfolk, that's the track that brings us the heaviest snow for our region. And so that low track is very important. If it's a little bit further to the west, typically we get warm air here and maybe just some rain or a wintry mix. If it's a little bit further to the southeast of that track, then we may not get anything at all. So it's really a narrow window of opportunity for winter storms in our region. And the other thing that complicates winter storm forecasting for our region is a pretty standard, typical thing that happens, which is warm air likes to move north, and it kind of gets shunted west of the mountains, west of the Appalachian Mountains, and it can be be above the ground. You can see in this graphic here, the orange on the map is that warm nose of air that we often have to deal with. And if that warm air is really thick and reaches all the way to the ground, that snow falls from the cloud here on the left, and it melts and it falls as rain all the way down to the ground. Now, if that warm layer of air is a little thinner, it's still thick enough to melt the snow that falls from the ground. And then the cold air near the ground, you see here, is not thick enough to refreeze that rain. So that rain falls, but when it touches the ground and cold surfaces, then you can get freezing rain. We actually saw some of that yesterday in parts of our region. Now, if that warm layer of air is really shallow and there's a deep enough layer of cold air near the ground, then the snow melts, but then refreezes into sleet. And so this is what we have to kind of factor in because very rarely in our region do we get just a good old-fashioned just snowstorm. I can think back to January 2016 was the last time really this really happened for most of our area, where everybody just got snow. Usually we're dealing with this warm layer of air that comes in above the ground. Now, here's the problem. So on the left is our surface observation locations, and this is just airport weather observations. So we have those all over the place, and this is just airports. We also have personal weather stations. A lot of emergency management agencies across our region have installed weather stations, and so we get that data as well. And then just anybody, I mean, I have a personal weather station at my house, and as long as they're properly installed, they do a great job of letting us know what the temperature is at the ground level. So we have a really good handle on what's happening at the ground when it comes to temperatures and whatnot. The problem is, remember, that warm layer of air is above the ground, and the map on your right shows the upper air balloon launch locations. There's one in Wilmington, Ohio, Pittsburgh, Dulles Airport, and then Roanoke, and we are in a void here. And again, that warm air likes to come up from the Gulf of Mexico, and so we don't get that sampled very well because we don't have that upper air launch capability. And we do get some aircraft data. Believe it or not, aircrafts give us data as they land and take off from airports. But again, we're in a void here in our region. There is some scattered data that we can get in Charleston and Huntington that we're getting access to that really helps out. But those are few and far between. So again, we're having to make a lot of assumptions sometimes about the depth of that warm air above the ground, how deep it is, and how far north it goes. And the models, computer models we have to rely on, sometimes don't get that, don't do very well with that. So it's something that we have to really kind of factor in. And luckily we have some folks here at our office that have been here for a long time. They have 20 plus, 25 plus years of experience. And so they have that ability to take that into matter and tweak those forecasts based on their experience. But snow forecasting is the hardest thing we do. We have to get the temperature right, again, not only at the surface, but above the surface. We also have to get the liquid amount right, and that's the second hardest thing that we do, is to get the amount of rain or amount of precipitation, the liquid content of the snow, correct. And then we also have to figure out, is it going to be wet? Is it going to be dry? We have to get that liquid ratio correct. If we're off on any of these three areas, the forecast is not going to be correct. And so if we get any of that wrong, and we will, and it happens, then the forecast snowfall will be different from our forecast. The actual snowfall will be different from our forecast. So that's why we like to use ranges. We like to say there's going to be 2 to 5 inches of snow, or 4 to 8. You know, we like to talk about ranges, and sometimes those ranges are wider than others depending on our forecast confidence. And I'll show you here in a few minutes some products that you can use to gauge that confidence and understand that. But we need your reports. So everything I said complicates the forecast process. So a lot of times there's been situations where the storm is moving in, the precipitation is moving in from the south, and you know, we think we know what precip type it's going to start as, but then it starts precipitating, and we've got to change gears really quick because maybe we're expecting it to start as snow, and it starts immediately as freezing rain. And then we know at that particular moment that warm air above the ground, the models aren't handling it right, and we have to adjust our forecast. And the more reports we can get, the faster we can get them, the quicker we can get that forecast updated and make it more accurate for the end users, you and the public. So your reports are very important. Snow, sleet, freezing rain, I'll show you how to get those to us. But just understand that if you don't get anything else out of this webinar, that your reports of what it's actually doing out there are extremely important. And we've got a lot of different ways you can get that information to us, but it's just important that we get it. Freezing rain's a big one, and then the changing precipitation types. And there's actually an app you can use to report that we monitor here in our office. So when it comes to properly measuring snow, you can get really high tech with it. You can get a snowboard, which is a 2 foot by 2 foot piece of plywood painted white, or you can buy them, they're plastic or whatever, and stick it out, and that's what you measure on. You want to get it out away from trees in an area that's representative and it's easy to access, and that's not going to get trampled over. It's important to maybe mark it somehow with a flag or some other way to mark it. So if we do get a foot and a half, 2 foot of snow, you know where your board's at and you can measure on it. But if you've got a picnic table or a porch railing or something like that that you can measure on, that'll do. It's just important not to measure in grass because the grass will inflate the total that you have. So 2 snowboards are great. That way you can measure on one and you maybe take an intermediate report in the middle of the storm. Then you can leave the other one alone, and you can take a measurement on one, wipe it off, and that way you know how much snow you got for the next time you measure in between there. Typically we prefer measurements in 1/10 of an inch. It's not necessary. We can do the conversion if you say you got 1.5 inches or 1 3/4 inches, but we typically prefer those measurements, and we send those reports out in 1/10 of an inch. So when you take your measurements, we want to know about new snow. That's how much snow that has fallen since you last measured. And most of the time, new snow and snow depth will be the same thing here. Very rarely do we get storms that follow storms with snow already on the ground, but it does happen, especially in the mountains. So there are 2 different measurements. There's new snow, which is, again, is how much snow fell since the last time you measured, and then the snow depth, and that's just the total amount of snow that's on the ground. So those can be 2 different numbers, and those are what we want to know about. Now, when it comes to ice, ice is tricky. So you can measure ice radially, or like on a tree limb or a wire, or you can also measure it on a flat surface like a fence post or porch railing. Doesn't matter how you do it, just communicate to us how you've done it, because there is a big difference between flat ice and radial ice. You can see the equation. Flat ice equals radial ice divided by 0.4. So there's a big difference there, and we need to know what you're measuring. We actually forecast in flat ice. But of course, a lot of our utility partners, they want to know radial ice. They want to know how much ice is going to accumulate on the tree limb. So there's some conversions you can do there. But it's just the moral of the story is just be sure to communicate to us what kind of accumulation, how you took that accumulation, how you took that measurement. So how to send us a report. So this is our website on the left, weather.gov/CharlestonWV. and I want to show you how to get to a little web page that summarizes how you can get your reports to us with links. So if you go to our web page and then look for the Submit Storm Report, that green icon down at the bottom looks like a thunderstorm. That'll take you to this page. And so at the top is how to report with some links. And I'll go through these here in just a minute. Down at the bottom are what to report. So some extra information that you can look back on how to properly measure. Say how to properly measure snow. This will tell you how to do it. Also how to do freezing rain, icing, different variables there. So the best, easiest way to report to us is if you have our phone number, which, you know, our partners, we have a phone number for our partners that will ring through 24/7, and you can call us. But if you don't want to do that, a very easy way to report to us is using this web-based form. So it's the top one, submit report, submit report. I'm going to click on it. I'm going to show you how this works. So this works really well on a smartphone. It's how it's kind of configured. You can see on a web page there's not much to it, but there is a drop-down menu here, and you can select what kind of report you want to send. So let's say we're going to send a snowfall report. Click next, and it'll fill in the time. If you took the report maybe an hour ago, you can change that, but otherwise just leave the time alone, the date, and put your snowfall measurement in there. Say we've got 4 inches of snow, and I've actually measured it. So another thing that's important is if you're estimating it, let us know that. If you've actually measured it, click on the I measured the snowfall. You can put any kind of comments in there. I'll put it's a heavy wet snow. Then I'll click next. And then if you're on a smartphone, it'll know your location. You can use your device's current location. Where I'm on a computer, I'll put in our new office location here. Hendrickson Drive, South Charleston, West Virginia. And then you can click Find Address, and it'll pull up our location there. And then you click Next. So here's a summary of your report. It'll have your lat lon for us and how much you're reporting. You can put your name in there if you want. Again, we don't send this out, but we keep this internal, but we may want to contact you for some reason. You could put that in there. And then very important, if you're a trained spotter for us, or if you're emergency management or whatever, you could put emergency manager or media. If you're a trained spotter for us, which again, I'll talk about this during our public weather spotter class coming up tomorrow night, but we actually have a trained spotter field in there, and that allows us to provide proper attribution to our trained spotters. But that's it. You hit send report, we get notification on our internal system. And so it's a very easy way to get reports to us. So I'll go back to the slides. You could see some other ways to get reports, a spotter hotline or a partner hotline, the 24/7 number that you should have. If not, contact me, I'll get that to you. You can reach us 24/7. Facebook, Twitter, we monitor that during events. And then our email, if you get our briefings, rlx.ops@noaa.gov, we monitor that. You can send your report to that. And then also the MPing mobile app. And so this won't work very well on the PC, but if you can download the app on your smartphone, just search for MPING, and it's a very simple app that allows you to report precipitation type to us. So that's, again, very important as winter storms move into our region, what is actually occurring on the ground. And so you can use that app. It takes a couple little taps on your screen and you can get us a report. And so very helpful to us. And then at the bottom, you know, any reports that we get, we send those back out to the world. So the media sees them, our users see them, and you can access them here, clicking the links at the bottom of the screen here on this page that you go to. So again, your reports are very helpful to us, and we have a lot of different ways you can get them to us. Just get them to us because we really do need the ground truth information. You know, we're physically located here in South Charleston, but our area of responsibility is 49 counties in 4 states. And radar is great, but again, it's telling us what's going on up in the clouds, up in the sky, and what's happening on radar doesn't always make it isn't accurate at the ground. And then you folks up in Clarksburg or Elkins, you know, a lot of times it's snowing outside and you don't see anything on radar. That's a limitation of radar. So we do need that ground truth information. And so again, if you don't get anything else out of this webinar, just know that what you're seeing at the ground is important to us, and there's a lot of different ways you can get that information to us. And so this slide's very important. Now, there's also a day to get daily rainfall and snowfall information to us, because we don't have any automated equipment that measure snowfall. You know, we do rain gauges, we do temperature, but snowfall, we still rely on human beings to get that information to us. And then we also really like humans to physically measure the rain, and that gives us a check on our radar and our automated system. So CocoRaws is a great way to get that information to us. I'll click on the little link here on the slide, and this will take you to a web page that we have done up on CocoRaws. I think there's this would be really good for schools, science teachers. I think this would be a very good fit to get science teachers to observing the rain and snow every day and integrating it into their curriculum. So more information here. I'll show you. I'll click on the CocoRaws website and show you how many observers that we have in our region. And you could see that there's a lot of gaps. And so we could always use more observers. And again, I think a really good fit for this is with the schools, but anybody can do it. It's pretty easy. They just ask for you to get a rain gauge, a standard rain gauge. 4-inch rain gauge costs about 35 bucks, I think, and then to provide the information daily. All right, so now let's talk about forecasting the terminology and or knowing the terminology. So when it comes to winter storm products, we issue 3 main products, and those are issued hopefully well in advance. A winter storm watch, for instance, is your clue that a significant winter storm is possible. Now, we only have to have about 50% confidence in order to be able to issue that winter storm watch, but our confidence is typically high enough that there's going to be a very impactful system for our region, that we put that out usually a day or 2 in advance of the storm, and then from there, that we either upgrade that once our confidence increases that there's going to be significant impacts. We would upgrade that to a winter storm warning. And we have certain criteria for that warning, which I'll show you here in just a minute. But that's our confidence is high that there's going to be a significant winter storm threat. If our confidence is high that there's going to be a travel issue, there's going to be lighter precipitation, but it's going to have an impact on travel, the commute. But if people take the proper precautions, it's not going to be a life-threatening event. Then that's where the winter weather advisory comes in. Now, this is the criteria. You can find your county and our area of responsibility, and you can find the criteria for winter weather advisory issuance on the left and winter storm watch and warning on the right. And so just understand that we rely pretty strictly on criteria for the watch and warning issuances, but for advisory, say if we have a system moving through, it's only going to produce some light snow, but it's going to happen at, say, 7 o'clock in the morning on a Monday or Tuesday, key commute times. We can bend this criteria and issue a winter weather advisory just based on the impact that that system will have. So we do have some latitude there, so keep that in mind. And we have a lot of different ways to get weather information. One thing I always try to pass on to folks is that when you're looking at forecast information, it's really convenient to pick up this phone and just look at the weather app on it. The generic app, some of them are really good, but for winter storms, always get the local information, whether it's local media or the National Weather Service. Get that local expertise when you're looking at winter storm forecasts, because again, those are the most complicated things that we do, and it's important to have that local knowledge. The app on your phone is typically just computer model data, and you don't know where that originates at. There's not a lot of detail in there. So local media, the Weather Service, that local source, and you can see all the different ways that we have to get weather information. Our website, again, weather.gov/CharlestonWV. Hopefully you're aware of that. You can also go to weather.gov/your zip code, and that will take you to a page devoted just for that location. And you can dial that in and bookmark it, and then use that like an app on your phone. You can put that on your home screen, and every time you pull that page up, it'll pull in the latest information. Another pretty good page is our mobile.weather.gov. So we don't have an app. I always get that question, do you have an app? We don't, but we have this mobile web page that functions very much like an app. So I'm going to put in a location here. Let's say, let's do Athens, Ohio. I was just up in Ohio yesterday, so I've got some folks on here from there. But this is what the page looks like. So you're in Athens and you put this in, and you can see the current conditions. You can also see the forecast. And what I really like about it, and this, again, it's structured for a smartphone, so it'll shrink and expand based on the size of your screen. But hourly detail, we put these forecasts out and we have hourly detail down to 2.5 kilometer grids for 7 days. That's our National Digital Forecast database. So you can actually access hourly data by clicking on the little plus there, and this will tell you every hour what our forecast is for that day. And for tonight, we actually have a little bit of snow in the forecast there in Athens, and you can see that this evening there is a slight chance of snow, and then the temperatures every hour. So we put that hourly detail, and that mobile.weather.gov is a great way to get that information. Again, Facebook and Twitter, please follow us on there. We're always putting a lot of information when it comes to winter storms on our Facebook and Twitter page, and then we're getting information as well. So that's another really good way to contact us. Weather radio, again, local TV and radio, very important to get that local information. Now here's another, again, the weather.gov/your zip code will take you to that really hyper local page for your location. And if you scroll down on that page, you can actually access this hourly weather graph, which is, again, that hourly detail that sometimes you may need to get your information before a winter storm hits. You may want to know when's the precipitation going to start. And you can get that detail from that hourly weather graph. Now, the comprehensive winter weather forecast information page that we have here locally, and most weather service offices have now, is our winter page. And so you can go to the web address here, and I'll show you this. We actually have some winter weather to talk about, so I can show you a live demo of this page here in just a second. But if you go to our web page, or really any web page in the eastern part of the United States, and you look for the little blue snowflake icon down in the lower left part of the screen, and you click on that, that'll take you to our winter page. I'm actually going to click on this and give you a live demo here. Get rid of some of these other pages. And so clicking on our winter page right now, this is what it brings up. So we actually do have some snow in the forecast, and this is our forecast. So the bigger map is always going to be our forecast for that event. But again, like leading back on my forecasting winter storms presentation slides, there's a lot of complexity in forecasting winter storms. And so there's always a potential range of solutions. So we give you that potential range of solutions on this page. You can see the little map here on the upper right is the high end amount. So what's the when you're looking at all the potential probabilities, what's a realistic worst case scenario? Or if you really like snow, best case scenario. But what's a realistic worst case scenario? So here you can see our expected snowfall, where we're not really expecting much in Charleston or in Ripley or Spencer or Athens. We don't have any snow in the actual forecast, but you can see that there is a potential for a dusting of snow here in this lighter blue area. So while the forecast is not for really anything, in fact, I even heard our forecaster working the desk this morning talking about it. He said there is a potential for a dusting of snow in the lower elevations. So, and then here's the potential best case scenario, or low end amount based on the guidance. And you can see there's not much change from our forecast here. Sometimes you'll pull this up for winter storms and you'll see a big difference. We may be forecasting 4 inches of snow for your location. You click on this map and you see 12 inches. And then you click on this map and you see 0. So there's the goalposts are wide in that situation. So that you can surmise from that information that, hey, the forecasters are not very confident in this situation. I might want to plan for the worst case scenario, hope for the best. Sometimes, like in the situation here, those goalposts are real narrow. We're pretty confident in the forecast. There's not a lot of spread. So that's how you can tell, kind of gauge forecaster confidence. I will go ahead and click on some of the tabs here. You can see that we, as the State Liaison Office for West Virginia, produce graphics for the entire state of West Virginia. So you can click on West Virginia probabilistic snowfall forecast here. We have onset end time graphics. So you want to know when the precipitation is going to start. You can click on that graphic. When's it going to end? You can click on the graphic here and it'll show you. Now, sometimes these maps they're automatically generated based on our forecast, and they can be pretty messy because of our terrain and higher elevation. It typically starts first there and then works its way down. Sometimes it comes in from the west, and so it can get a little messy, but that's how we try to communicate that on this page. And there's also a link here for Winter Storm Outlook and Winter Storm Severity Index. So hold that thought. I'm going to show you more about that in just a minute. But I want to go back to my slide, and I want to talk about these other statewide graphics. I know we have partners on here from Ohio and Kentucky and Virginia. So if you want to know about the forecast, you can go to our page like I showed you, and yeah, you can get the forecast for our Southeast Ohio counties, our Kentucky counties, our 2 Virginia counties. But maybe you want to know about the snow for the entire state of Ohio. So you can access that from actually the Wilmington, Ohio National Weather Service office. They are the state liaison office for the state of Ohio, so they generate those graphics. And so you can click on the Ohio probabilistic snowfall forecast, get that information. And same for Kentucky, those are generated from the Louisville office. And then Virginia, they're issued by the Wakefield, Virginia office. So those statewide graphics are available. If you're inside our region, you can get to it from, your forecast from our page, but I didn't want to show you that those are available. And the Winter Storm Severity Index. So again, you can access that from those winter pages. There's always a thumbnail that you can click on. I'm getting some good feedback from this from partners, and it's only been around for a couple of winters, but people that have used it seem to like it. And it basically looks at several variables and gives you an idea of how severe the winter storm is going to be, not only based on just snow amount, because 4 inches of snow in Huntington, West Virginia means a lot more than 4 inches of snow in Buffalo, New York. So there's a regional susceptibility threshold in there, and it factors that in. But it tries to give you an idea of impact based on 6 different variables. Snow load, which is the weight of the snow. Is it going to be a light snow, wet snow? Snow amount, ice accumulation, ground blizzard, which we don't have to deal with here in our region too often. But the other one's a flash freeze. And this can be during and after precipitation, and then blowing snow. So factoring all these ingredients together, what's the impact of the event going to be? And so I can click on the link here to show our region over the next 3 days. And you can see based on our forecast from these variables, there's winter weather expected across our region, but the impacts aren't going to be very severe for that. Now you go up into the Great Lakes, you may have heard they're expecting some pretty significant lake effect snow, and you can see that this is potentially going to have extreme impacts for the Buffalo area. So that's something to watch for Thursday into Friday. But use this, check this out, check it out this winter. Let me know how you like it. Like I said, I'm hearing some feedback from some emergency managers that it's a pretty nifty little product and can certainly give you an idea of how severe the next storm is going to be. So now I want to talk about the Graphical Hazardous Weather Outlook, and I like to refer to this as our weather hazard dashboard. Again, from our website, look for the little brown icon that says Graphical Hazards down in the bottom part of the screen there. You click on that and it'll take you to this dashboard. And so I'm going to click on ours right now because again, we have some weather. I can give you a live demo. And so when you pull this up, it'll look at the worst case weather element over the next week, and it'll show you the graphic for it. And for us, it's snow tonight and tomorrow night. You can see that there is an elevated risk of snow in our mountains, and with a couple inches likely. Now the thresholds here are a little different than that winter storm severity index, so just keep that in mind. But you can scroll down and you can see the categories and what that means. But then over at the right, you can see over the next 7 days, these little chiclets, these little icons light up whenever there's weather. And so we're expecting wind. Again, you can click on that. The map will change to show you where that wind threat is at. And it's mainly confined to the mountains over the next several days. There's also excessive cold, again, mainly confined to the mountains. Now you can access this for the entire state of West Virginia. If you want to see the entire region by clicking on the little zoom area, click West Virginia, and that'll do the same thing for the entire state plus our other regions. We do have statewide graphics available at the links here for the entire state of Ohio and the entire state of Kentucky. I wasn't able to find these for the entire state of Virginia just yet, but I'm sure they'll be, the Wakefield office is responsible for that. I'm not sure if those are available yet. But this is a really good thing to have up and check every day just to get a real good snapshot of any kind of significant weather that could occur, and then you can dive down deeper if you want more information. Okay, so be sure if anything caused a question, type it in there. I do see a couple questions, so I'll be sure to get to those when we get down to the end of the presentation here. But I want to switch gears and talk about a few case studies of some problematic winter weather. And so hopefully I'm not a very good forecaster when it comes to the week that I'm going to be talking about, but it's a rough week, challenging week weather-wise in the near future. So we'll go through this. So I want to talk about the importance of monitoring dew point temperature. It may be something you have never thought about, but I gave a presentation for the DOH in West Virginia back last month, and they wanted me to talk about this. And I thought, well, I'll go ahead and include this information in our partner webinar as well. You do see the TV meteorologists talk about dew points sometimes. You can see it in the weather observations that are communicated on our website. And can be a pretty important variable. So the dew point is the temperature at which the air must be cooled for saturation of the air to occur. So a lot of people talk about relative humidity. I actually prefer dew point. I know that if the dew point's 70 degrees outside, I'm going to be sweating as soon as I walk out the door. I know if the dew point's 10 degrees, it's dry, you know. And so that is a very easy way to know exactly how much moisture is in the air. Now the spread between the temperature and the dew point, when that's large, then incoming precipitation sometimes might not even reach the ground because the air near the ground is very, very dry. But sometimes it does reach the ground after a point, and what happens to the temperature in that situation is very important for forecasting winter weather, because that temperature will want to fall towards the dew point and potentially below freezing. So let's look at a scenario here. This is, again, hopefully I'm not a very good forecaster, and this doesn't actually happen. This is hopefully going to be a fictional scenario, but say it's 4:30 a.m. on Monday, December 12th, and the forecast is calling for snow to begin at 6 a.m. This would be the first snow of the season. Automatically, that should ring alarm bells. The first snow of the season is always tricky for folks. And here's the radar view showing precipitation moving in from the west. The temperature on your thermometer says 34, but the dew point's 24. So you may think, well, it's 34 degrees, shouldn't be a problem. Road surface temperatures are also around 34 degrees. So you're thinking maybe, well, maybe it's not going to be a problem. Here's our forecast. Snowfall, you can see we're expecting about a ½ inch across our region, maybe a little more down towards Beckley and Grundy, Virginia, but generally less than an inch across the entire region. Here's that winter storm severity index. Now notice, again, there is the snowfall forecast is about the same. Even at Snowshoe, 0.7 of an inch. Huntington, 0.4 of an inch, not that big a difference. But notice how the winter storm severity index shows that this could have a minor impact in the lower elevations, because there is a difference. People in the mountains, they can handle ½ inch of snow a little better than you can on I-64 between Huntington and Charleston, we'll say. So there is a little bit of a difference there, and that's good. So here's what happened. So the snow began very lightly with a temperature of 34 degrees. The dew point was 24 degrees. But notice as the snow picked up in intensity, that temperature fell towards the dew point and actually cratered around 29 degrees right in the middle of the morning rush. What's a potential outcome when this happens? Well, this did happen last year, last December 8th. A very similar scenario happened, and we had a lot of accidents around the region. And it was a tricky situation. Not a lot of snow, but big impacts. And so this is something to factor in, and we factor in really when we're trying to forecast winter storms. A minor variable, the dew point temperature, but it makes a huge difference. Here's scenario number 2. So it's a little later in the week. It's 5 a.m. on Thursday, December 15th. It's been very cold over the past couple of days. After that system moved through on Monday, it got very, very cold. Road temperatures are in the mid-20s. Air temperatures overnight have warmed to 34 degrees, and that dew point's 32, so a very narrow spread. And it's foggy outside, so there's a lot of humidity in the air relative to the temperature. And so I know this graph's very complicated, but the top temperatures, air temperature in red, The green line is dew point temperature. Again, they're above freezing, above 32 degrees. But that road temperature in blue and the bridge temperature in pink is below freezing. So what this actually happens is the condensation can form on the road. And even though the temperature is above freezing, those roads are below freezing. You can see that the roads here were partially ice covered. And this is actual measurements of what actually happened in this scenario. And so the road was partially ice covered. Wasn't precipitating, it was foggy, and there was condensation forming on the roads and particularly the bridges. So again, this is very tricky situation because we're not forecasting any precipitation, but you can get impacts in this particular situation. Scenario number 3. So now it's noon on Friday, December 16th. Yep, it's been a very busy week. We're tired. But you've been hearing the weather folks mentioning the potential for snow squalls during the afternoon. Air temperatures are in the mid-30s. Pavement temperatures are in the mid-30s. The sun's even out. But you pull up the phone and you see snow showers moving towards your county. So snow squalls are another problematic scenario in the winter. These are kind of like you think about it in the summer, your thunderstorms. These are very similar. They're convective snow showers. They bring strong gusty winds like a thunderstorm would in the summer, and brief accumulations, brief, very low visibilities. And so here's the image here on the left is a snow squall moving in. It looks like a curtain of white just moving towards across the city. And here's what happens when the snow squall hits. You go from great visibility, the sun's out, to a whiteout, and you can't see anything. Notice the snow accumulating rapidly on the roads, because also a lot of times the temperature plummets in a snow squall, and you go from that 35-degree temperature down to maybe 28. And the road also responds really quickly, and you can get some multi-car pileups in these situations. So again, the important consideration is that temperatures can plummet below freezing quickly, and you get a sheet of ice developing on the roads. And then also the rapidly fluctuating visibility. People have a tendency not to want to slow down and correct for that rapidly changing visibility, and one mistake can cause a multi-car pileup. And there have been pileups of 70, 80 cars in some of these instances. So we will continue this winter issuing snow squall warnings when we expect these to occur. And again, the criteria is pretty strict, and but these will alert cell phones. Now, in the past, every time we issued these, they would alert wireless emergency alerts and set off your cell phone. Now we have the ability to put a trigger in there, and so if we don't want the snow squall warning to set off cell phones, we can make sure that doesn't happen. So what we're going to be doing is focusing these, especially the alerting snow squall warnings that'll set off cell phones right on the major highways. And so, and the way wireless emergency works is somebody can be traveling and they enter that warning area heading towards that snow squall, and their cell phone will go off and let them know that they should be aware of rapidly changing visibility, rapidly deteriorating road conditions, and in those snow squalls. And we work with the Department of Highways, especially in West Virginia, and they actually put that kind of messaging on their message boards along the interstate. So I want to bring that up. Those are 3 kind of different scenarios, ones that we don't see very often, but they can cause some big impacts across our region. All right, so now let's talk about the winter outlook. And so what's it mean? So the winter outlook, NOAA issues the winter outlook every October. We're kind of late to the game. Typically the Farmer's Almanac comes out in August, and we start getting questions about what the winter outlook is going to be. And of course, everybody does their whole woolly worm canvas. I do my own personal woolly worm canvas around the office and at home. Here's some of the ones I've seen this year. The white one really worries me. That can't be good. Persimmon seed forecast. When I worked in Kentucky, this was big, the persimmon seeds. So apparently if you see a lot of spoons when you cut your persimmon seeds open, that means a hard winter is ahead. And so you can see this, a lot of spoons in those persimmon seeds here. Folklore, does it mean anything? It does to some people, but we kind of look at a more science-based forecast, and I'll show you that in just a minute. The Farmer's Almanac and the Old Farmer's Almanac are out there. Everybody's seen them. They're pointing both towards a really cold winter ahead. So I don't know how they come up with their forecasts. They don't show that information. And one of these has, I think the Farmer's Almanac has been saying unseasonably cold and snowy for about the past 4 winters, and it hasn't really materialized overall. So anyway, I just wanted to show that they're out there. If you haven't seen them, you must be living under a rock, because we hear about them a lot. But what's the winter ahead? What are we basing our forecast? When I say we, I mean the Climate Prediction Center, which is part of the National Weather Service. They base their forecast really intensely on what's going on in the Pacific Ocean with La Nina or El Nino. And the past 2 winters have been La Nina winters. You can see the sea surface temperature map here on the right, and the blue in the Central Pacific is that La Nina pattern of cooler than normal water temperatures out there in the Central Pacific. And this will be the 3rd winter in a row with a La Nina pattern in place, which is kind of unusual. Typically they run in either a 1 season or 2 consecutive seasons, but 3 consecutive seasons is a little odd. But there are pretty predictable weather patterns across the Northern Hemisphere when you have La Nina. And so that typical pattern is shown on the map on your bottom right. And for the Ohio Valley and the Mid-Ohio Valley and the Central Appalachians, typically that's a wetter than normal outcome, and a little bit warmer than normal, especially as you get into West Virginia. Now, here's the way it shook out. Again, this is the 3rd consecutive La Nina winter. Last winter, December 2021 through February 2022, kind of behaved as you would expect it. We were warmer than normal and much wetter than normal in the Ohio Valley. It was a pretty wet year. But the previous winter didn't behave as normal. You may remember the really, really cold weather in Texas, the record-breaking cold in Texas, and overall it was colder than normal winter there. So not really your typical La Nina. And I say that because sometimes some factors come in, some harder to forecast things, some patterns come in that override the La Nina signal. So even though the forecast that I'm showing you now for the winter ahead is really heavily based on that La Nina forecast, where especially in the Ohio Valley, the wetter than normal winter, it does look like that we are setting up for another wetter than normal winter, especially in Southeast Ohio and Kentucky and the northern part of West Virginia. Elsewhere, a little harder to predict. So the equal chances here. It's equal chances for above normal, normal, or below normal precipitation for the rest of West Virginia and eastern Kentucky and southwest Virginia. Temperature-wise, the far eastern part of West Virginia has a greater than normal chance of seeing above normal temperatures, but the rest of the area is kind of equal chances, kind of not really sure which way it's going to lean. But just keep in mind, there's a lot of other complicating factors that could come in that could throw us for a loop. It's really hard. I've talked about how hard it is to forecast winter precipitation a couple days in advance. When you're talking about forecasting months in advance, it's really, really difficult. But that's the signs that we're seeing, and that's the forecast for our region. And so the main talking point there is for continued. Yeah, we're dry now. We've had some wildfires up until the past week, but overall the winter should be wetter than normal, especially for the Mid-Ohio Valley. You may be wondering about snowfall. Well, we don't issue seasonal forecasts for snowfall just due to the complexity and how hard it is to predict. But we can look at overall La Nina years and see how snowfall behaved in our region. And snowfall tends to be highly variable during La Nina winters, but the trend is for typically average to below average snowfall. And that's been pretty consistent the past 2 winters. We had some big snows. Last winter we had some pretty good snows, especially in the Metro Valley here. We had 2 8-inch snowfalls at my house in Hurricane, and so we had some significant snows, but overall the winter pattern was normal to below normal. And we had the big ice storms back in 2021. So something to keep in mind, that we can get some big winter storms, even though the overall winter is expected to be average to maybe above average temperature-wise with La Nina winters. Okay, so that's all I have for that part of the presentation, the winter outlook. Again, if you have a question, you've still got some time to type that in. But I did want to do a plug. We monitor a lot of webcams in our operations area, and our forecasters are always wanting more webcams, and they're really important for winter storms. Again, getting that ground truth. Is it snowing? Is it sticking? Got a lot of DOH cameras, a lot of other public cameras out there, but you can see they're all plotted on a map here that we can monitor. But you see a lot of gaps there. There's a lot of gaps in Southeast Ohio, Central West Virginia, down in the Eastern Kentucky. There's not a lot of cameras there that we have to view. So if you're aware of cameras that we can access, we would love to have access to those, and we'll keep them internal. We won't publicize them, but they're for situational awareness purposes only. But there's you can contact me or John Peck at the email address on your screen there, and we can add those cameras to our situational awareness. But again, any cameras that you have, we would very much appreciate. So that's all I have. Again, if you have a question, you can raise your hand, or probably easier just to type it in there. I'll look at the questions here. Let me expand this out a little bit and see what we've got. So I missed you, Stephanie. Good morning. A little late. So spotter IDs. Lori Price wanted to know about spotter IDs. We don't do spotter IDs at our office. We don't keep up with those. So if you are a weather spotter for us, all you have to do is just identify yourself as that, and when you call us or when you communicate with us, but we don't keep up with those. So that's all the questions I'm seeing. Don't hesitate to send me an email or give me a call if you do have a question. I hope you found this webinar useful, got some good information from it. I'm always looking for feedback because I try to do these every winter, and I also try to do them in the spring, just to keep you all updated on some new products or changes, or just a good refresher on the season ahead. So I hope you found it useful. See a question here. What about signs of a weakening La Nina? Yeah, La Nina, it's pretty stout right now. It could weaken. However, the overall forecast is for it to remain in place throughout the winter, and then probably transition to neutral later next year. So it's something we'll watch. But that's the current idea, is that it will remain in place pretty much all winter long. So good question there. And again, the Climate Prediction Center, you can Google that, and they have a lot of good information on their website about longer range outlooks and forecasts. So they're the resource there. So good question, Khalil. Thank you. All righty, well, that's all we got. Again, don't hesitate to give me a shout if you have a question. I appreciate your time this morning. This will be recorded, and we'll include the slides, and so you can dive in a little deeper if you want to, but I'll get that out hopefully later today or tomorrow. But again, thank you for your time. Have a great day, and enjoy the holidays.